Have you ever wondered what the far, far future holds? Not just a few hundred years from now, but thousands, millions, even trillions of years into the future. It's a journey that stretches the limits of our imagination, a story of cosmic proportions. So, buckle up, because we're about to embark on an epic timeline, a journey to the very end of time. Right now, we're living in what scientists call the Timelapse era, the age of stars. The universe is full of them, lighting up the night sky and fueling life on planets like ours. But this stellar light show won't last forever. Let's fast forward just a little bit, say 100,000 years from now. By then, the constellations we know and love will be completely unrecognizable. The stars are all moving, and their slow dance across the galaxy will have rearranged them into new patterns. The Big Dipper? It might look more like a strange squiggle. Jump ahead to 500,000 years, Earth will likely have been hit by a sizable asteroid about a kilometer in diameter. It's not an if, but a when. And in about 1 million years, Betelgeuse, that bright red giant star in the Orion constellation, will have likely exploded in a spectacular supernova, briefly outshining the moon in our night sky. Now, let's make a bigger leap. 50 million years into the future. Africa will have collided with Eurasia, closing the Mediterranean Sea and creating a massive new mountain range, possibly even taller than the Himalayas. Our planet's geography is always changing. In 250 million years, the continents will have merged again, forming a new supercontinent. Pangea, Ultima, some call it. What would life be like on a world like that? It's hard to even imagine. Let's speed things up. In 600 million years, the sun's increasing brightness will start to have a major impact on Earth. The process that locks carbon dioxide into rocks will be disrupted, causing a runaway greenhouse effect. The oceans will begin to boil away. Life on the surface will become impossible. By 1 billion years from now, our sun will be about 10% brighter than it is today. The Earth's surface temperature will soar to over 47 degrees Celsius. The oceans will be gone, evaporated into space. Our beautiful blue marble will become a dry, barren wasteland, much like Venus today. The final curtain call for any complex life on Earth. Let's push further into the truly deep future. 5 billion years from now, our sun will run out of hydrogen fuel in its core. It will swell into a massive red giant, engulfing Mercury, Venus, and very possibly Earth. Our planet will be vaporized, its atoms scattered into the sun's outer layers. A dramatic end for our home. After its red giant phase, the sun will shed its outer layers, creating a beautiful planetary nebula. And its core will collapse into a white dwarf, a hot, dense, Earth-sized ember, slowly cooling in the darkness of space. Now, we're really getting into cosmic timescales. 1 trillion years from now, that's a 1 with 12 zeros. The Timelapse era, the age of stars, will be drawing to a close. Star formation will have ceased. The universe will have used up most of its available gas. The last of the small, long-lived red dwarf stars will finally flicker out, plunging the universe into darkness. This marks the beginning of the degenerate era. The only objects left will be the remnants of stars, white dwarfs, neutron stars, and black holes, all drifting silently through an increasingly empty cosmos. The universe will be a cold, dark, and lonely place. Galaxies will have dissolved, as these stellar remnants are either ejected into intergalactic space or fall towards the supermassive black hole at their center. Over unimaginable timescales, even these degenerate objects will begin to decay. On a timescale of 10 to the power of 40 years, that SA1, followed by 40 zeros, protons themselves might start to decay, according to some theories. If this happens, all ordinary matter will slowly dissolve into a sea of lighter particles like photons and electrons. The universe would become a thin, featureless soup of radiation. White dwarfs will slowly evaporate. And what about the last holdouts? The black holes. They are the ultimate cosmic survivors. But even they are not eternal. Thanks to a process called Hawking radiation, black holes slowly, very slowly, lose mass and evaporate. A stellar mass black hole will take around 10 to the power of 67 years to disappear. The supermassive black holes at the center of galaxies. They'll last for an astonishing 10 to the power of 100 years. A number so large, it's called a googol. Once the very last black hole has evaporated in a final faint flash of particles, what's left? This is the black hole era, followed by the dark era. The universe will be almost perfectly empty, a vast, cold, and dark expanse filled with only a diffuse gas of photons, neutrinos, and other elementary particles, all getting further and further apart as the universe continues to expand. Time itself might lose its meaning. With nothing happening, no events to mark its passage, is time even a relevant concept anymore? This is the potential end. Not a fiery apocalypse, but a quiet, cold, and eternal darkness. A state known as the heat death of the universe, where everything is at the same uniform, near absolute zero temperature, and no work, no change, no life is possible. It's a sobering thought, isn't it? From the vibrant, star-filled cosmos we know today, to a silent, empty void. But here's the thing. This journey to the end of time, while seemingly bleak, also highlights just how incredibly special this moment is. Right now, we live in the cosmic springtime, a fleeting but glorious era when the universe is alive with stars, galaxies, and at least on one tiny blue dot, life that can ponder its own existence and the fate of everything. The future is unimaginably long, and our moment in it is brief. But it's a brilliant moment. Let's appreciate the light while it lasts. If you enjoyed this cosmic trip, don't forget to like, subscribe, and hit that notification bell for more explorations into the wonders of our universe. See you in the next one.